Hi, it's Kevin from Kevin's Classroom. We're going to look at how to look at changes in pressure, disturbances of equilibrium. So let's just start off with a balanced chemical reaction, and I'm going to start off with the old favorite, the ammonia plus H2, and I have to balance it obviously, and I'm going to say that's going to be a 3H2 gas over here. My two ways going to 2NH3 gas over here, and they tell me delta H is less than naught. Delta H less than naught, the moment they tell you that and talk about temperature, I am going to do the following. Temperature, okay, you can write down your mole ratio because we're going to use it later. Temperature, you always draw the curve. They have told me it's exo. So I draw an exo curve, I put in reactant, product, forward, and I put in reverse. I label my product, my thing like this, which is exo, and reverse then must be endo. Okay, that tells me now let us say temperature goes up, right? What do I say? Temperature always going up favors the endo, Maxwell-Boltzmann, doesn't it? Okay, it's going to favor the endo. So what will happen in this case? It'll favor the reverse reaction. Therefore, less product and more reactants. Essentially, you're going to slow your chemical reaction down until you stop it. Therefore, we can say the concentration of reactants goes up and the concentration of product goes down. Where are we going to use this? We're going to use this when we get to the equilibrium constants. Now, I say, right, what about if T goes down? Well, T going down favors the exo in this case. Exo. Therefore, what is going to go down? Therefore, concentration of reactant goes down. Number of moles of reactant goes down. And concentration of product goes up. Number of moles of product goes up. Right? So that's the way we deal with him. How do we do pressure changes on this? Let's just move it up. Let's look at pressure. Okay? Pressure, you write down your equation. N2 gas plus 3H2 gas going to 2NH3 gas. You now say to yourself, right, please note, they are all in the same phase. Okay? They're in the same phase. Why? Because pressure only affects gases. NB. So if one is a liquid, you discard it. You do not use it. Then I say on this side I have got 1 plus 3 moles. On this side I've got 2. So this is a 4 mole and a 2 mole. Okay? What does that mean? It means the higher the moles, the higher the pressure. So that's the high pressure side. This is the low pressure side. So now, if I take pressure and I increase pressure, what do I get? Increasing pressure is going to say, Le Chatelier is going to say, don't want to do that. Make it lower. So it's going to favor the forward. Therefore, using reactants, and making product. Using reactants and making products, it does that version. Obviously, if I go and I reduce pressure, if I take pressure down, Le Chatelier says, put the pressure back up. So it's going to favor the reverse reaction. So the number of moles tells me where it comes from, and basically that comes from your PV equals nRT. That over there is your number of moles with the pressure, volume, and temperature relationships. Cheers, have a wonderful day.